The slope of a line describes its steepness and whether the line rises or falls from left to right. So the slope of a line M is the ratio of its rise, which is its vertical change, to its corresponding run, which is its horizontal change. So you have points P1 and P2. The run would be its horizontal change from this point to this point. This would be x2 minus x1. The rise is its vertical change, and that would be from this point to this point. This would also be y2 minus y1. Note that when we are working with slope and determining points, we're actually creating 90-degree angles. Here's the formula for slope. You've learned this in algebra. Slope, or M, equals rise divided by run, or y2 minus y1 divided by x2 minus x1. The slope of a horizontal line is always 0. There is no slope. This is the line y equals 5. There are not 2 points for us to subtract to determine a slope. Vertical lines are undefined. This vertical line is x equals 5. Let's take a look at example 4a. Example 4a is on page 131 of your book. Find the slope of each line. The first thing that you want to do is select 2 convenient points and find the rise and the run of those points. What they mean by convenient points is points that actually meet at the intersection of corners of your graph. The idea is to create a 90-degree angle. So then, after you've selected 2 points, calculate the ratio m equals rise over run. In this example, the rise would be from this point down to the horizontal line that we've drawn. So we go down 1, 2, 3. So the rise is -3. And here you can see it in your formula. The run will be going from left to right, and that will be 1, 2, 3, 4. So that'll be a positive 4, and here it is in your formula. -3 divided by 4 is the same as saying -3/4, which equals -0.075. Example 4b on the same page. Now this one has sets of points, and they want you to find the line through the points. Let's go ahead and label our points. Substitute the 2 sets of points into the slope formula and simplify. So here we have our slope formula, and we need to substitute y2 minus y1. So y2 was the coordinate 2, y1 was the coordinate -4. And below, we need to substitute x2 minus x1. So x2 was 3 minus 1. So 2 minus negative 4 is the same as saying 2 plus 4, which is 6. 3 minus 1 is 2. And 6 divided by 2 is 3. So the slope of this line is 3. We have two postulates in this presentation. We have the parallel slopes postulate, postulate 3.4.1. Non-vertical lines are parallel if and only if they have equal slopes. Any two vertical lines are parallel. So they're actually stating two things here. We know that two vertical lines are parallel. But non-vertical lines, these are lines that might go in different directions, are parallel if and only if they have equal slopes. The perpendicular slopes postulate, postulate 3.4.2, non-vertical and non-horizontal lines are perpendicular if and only if the product of their slopes is -1. We're not talking about the lines on a graph that run like this. We're talking about if they are at angles. The product of their slopes together would be -1. What we're saying here is when you have a situation like this, you would have -a times 1 over a, which is its reciprocal. Many times you'll hear this explained as slope for perpendicular lines would be a number times its negative reciprocal. And we'll see how this is going to be used. So example 5, use the following points to determine whether each pair of lines is parallel, perpendicular, or neither. So let's look at, say, lines AB and CD. We're going to use the slope formula for both. And with line AB, we have points -3 and 4, and 3 and 2. So we go ahead and use those points and substitute them into the slope formula, and we solve and find that we have a slope of -1/3. Now we were going to compare that to line CD, so we use the points 1 and -4 and -2 and -3. We substitute those into the slope formula, and we also end up with a slope of -1/3. That means that lines AB and CD are parallel because their slopes are equal. Now we're to compare lines AE and BC. So we use the points from A and from E for our first slope formula, and we substitute into the formula, and we end up with a slope of -1/3. Now, let me change colors here. Now if we use the points B and C, we substitute those numbers into our slope formula, and we solve and find that we have a slope of 3. Now 3 times -1/3 equals -1. So 3 times -1/3 equals -1. That means that the lines are perpendicular. For lesson 3.4, the second part, you're to do page 132, numbers 13 through 20, number 23, and number 24. You can attempt number 26 for 5 extra credit points, but make sure you do all of the other problems first. Some hints for your homework for number 13 through 18. Use the formula for slope of a line. You will only have one answer in these problems. For numbers 19 and 20, they will be worked like example 4a. Find convenient points and solve the rise over run. For numbers 23 and 4, find the slope of each line, name the parallel lines. And as an example, the answer in number 25 would be B is parallel to C, and the second half of the answer would be the slope equals 1. Be sure to record the slope formula and the 2 postulates in your notes. Let's take a look at problem number 25. So use the slope formula to determine which lines in each graph are parallel. Name the parallel lines and state their slope. So these 3 lines may look parallel, but we don't know that they are until we solve their slopes. Let me go ahead and change colors here. So let's look at line A. The measure of line A is determined by the convenient points that we find. So I found a convenient point down here on the horizontal axis, and I found another place right here on the line that is the corner of a square. I mark those points, and then I draw a dotted line just to give myself a good visual. Okay? From this point at the corner of this angle that we created, from this point to this point, going left to right, is 6 squares, so I've marked 6. To this point, and I'm sorry, from this point and from this point to this point are 5 spaces. So the slope of line A is 5/6. Now I have the 2 convenient points here, and I'm going to go from left to right 2 spaces, and I'm going to go 2 spaces here also. So I'm going to be consistent in the direction that I went with my other angle, and the slope is 2 over 2, which is 1. And for line C, I picked 2 convenient points. Here is our angle. From left to right, we have 4 spaces, and we have a rise of 4 spaces also. So 4 divided by 4 equals 1. So looking at all 3 of the lines, we had 5/6 as a slope, 1 as a slope, and 1 as a slope. So line B and line C are parallel, and their slope was 1. Hope this helps. Contact me if you need assistance with these problems.